Have you ever wondered how 3D printing works? Welcome to the fascinating world of 3D printing, a realm where creativity meets technology and imagination turns into reality. The inception of 3D printing dates back to the early 1980s, a brainchild of an engineer named Chuck Hull. Since then, this technology has been revolutionizing various industries, from manufacturing to healthcare and even the food industry. 3D printing, also known as additive manufacturing, is the process of creating three-dimensional objects from a digital file. It's like having a personal factory at your fingertips, capable of producing complex designs layer by layer. The importance of 3D printing cannot be overstated. It has democratized the production process, making it accessible to anyone with a computer and a 3D printer. This technology has a wide range of uses, from creating prototypes to producing intricate jewelry, medical tools, and even houses. Now that we have a basic understanding of what 3D printing is, you might be wondering, how exactly does it work? A 3D printing, also known as additive manufacturing, is not as complex as it might seem. The magic begins with a 3D model. Think of this as the blueprint of your soon-to-be tangible object. You can create this model using various 3D modeling software, or if you're feeling less adventurous, you can download pre-existing designs from online repositories. This model is usually saved in a format known as STL, which stands for stereolithography. Once your 3D model is ready, it's time for slicing. Not literally, of course. In the 3D printing world, slicing is the process of dividing your 3D model into hundreds or even thousands of horizontal layers. This is done using slicing software, which translates these layers into a language that the 3D printer understands. It's like giving the printer a detailed roadmap, guiding it layer by layer until the final product is complete. Now, on to the most exciting part, the printing process. This is where your design comes to life. The 3D printer starts at the base, following the instructions from the slicing software. It deposits material, usually plastic or metal, one layer at a time. These layers bond together to form your 3D object. It's like building a sandcastle, but instead of sand, you're using thin layers of material, and instead of a bucket and spade, you're using a high-tech machine. Throughout the printing process, the printhead moves around, heating up the material until it melts. As it cools down, it solidifies, taking the shape of your design. This process is repeated over and over for each layer until your object is fully formed. Depending on the complexity and size of the design, this could take anywhere from a few hours to several days. 3D printing unveils a world of infinite possibilities, from intricate jewelry to life-saving medical devices, from miniature models to full-scale houses. The limit is truly your imagination. And the best part? You can do it all from the comfort of your own home. And just like that, you've created a physical object from a digital design. 3D printing has become an indispensable tool in various industries. This revolutionary technology has transformed the world of manufacturing, healthcare, automotive, and so much more. But why is 3D printing gaining such traction? Let's delve into the importance and advantages of 3D printing. In the realm of manufacturing, 3D printing, also known as additive manufacturing, has become a game changer. It allows for rapid prototyping, enabling designers and engineers to bring their ideas to life swiftly and efficiently. Gone are the days of waiting for weeks or even months for prototypes. Now they can be produced in just a matter of hours or days. This speed and efficiency can significantly reduce the time to market, giving companies a competitive edge. But it's not just speed that sets 3D printing apart. It's also incredibly cost-effective. Traditional manufacturing methods often involve expensive molds and require large production runs to be economical. With 3D printing, each item can be produced individually, eliminating the need for costly molds and enabling small production runs or even single items to be produced economically. Beyond manufacturing, 3D printing has also made significant strides in healthcare. It's being used to create custom prosthetics and implants tailored to the individual patient. This level of customization was previously unthinkable and has the potential to greatly improve patient outcomes. In the automotive industry, 3D printing is driving innovation by enabling complex parts to be produced more easily and at a lower cost than with traditional methods. This not only reduces the cost of production but also allows for more innovative and efficient designs. But perhaps one of the most exciting aspects of 3D printing is its potential for personal use. The accessibility and affordability of 3D printers mean that anyone can become a creator, designing and producing their own items at home. With so many advantages, it's no wonder more and more people are getting interested in 3D printing. Believe it or not, you can build a 3D printer at home. And the beauty of it? You don't need to be a rocket scientist to do it. With a little patience and some basic components, you can have your very own 3D printer up and running in no time. First things first, let's talk about what you're going to need. For the structure of the printer, you will need some aluminum extrusion profiles. These will provide the framework for your printer. You'll also need a set of smooth and threaded rods for the printer's axis. Next up is the print bed, the surface upon which your 3D object will take shape. A heated bed is a good option here as it helps with the adhesion of your printed object. Then we have the extruder, which is essentially the pen that your printer uses to draw your designs in 3 dimensions. The extruder heats up the filament and pushes it out onto the print bed layer by layer, creating your 3D object. Now let's talk about the brains of the operation. The Arduino. The Arduino is a microcontroller board that tells your printer what to do and when to do it. It receives instructions from your computer and translates them into motor movements. This is what makes your 3D printer move and create. You'll also need stepper motors to control the movement of the extruder and the print bed. These motors will be controlled by the Arduino to ensure precise movements. Lastly, you'll need a power supply to power up your 3D printer and, of course, 3D printing filament. This is the material your printer will use to create your 3D objects. Remember, safety is paramount when working with electrical components. Always make sure your workspace is clean, organized, and free of any unnecessary clutter. It's also a good idea to use a surge protector for your power supply to avoid any electrical mishaps. Now that we've got our components ready, let's get to the fun part. Building a 3D printer might seem daunting, but it's actually quite straightforward. Let's begin with the frame. A sturdy frame is a must as it provides foundational support. Opt for aluminum or steel frames for the best results. Start by assembling the base, then attach the vertical components. Be mindful to keep everything square and level. Now let's move on to the stepper motors. These will control the movement of your printer. You'll need 3 motors, 1 for each axis. Mount your motors to the frame, ensuring they're securely fastened. Next up, we'll install the extruder. This is the part that heats and pushes out the filament to create your 3D models. Mount your extruder onto the carriage that moves along the x-axis. Make sure it's lined up correctly with the motor. After that, it's time for the hot end. This is where the filament melts. Connect the hot end to the extruder and ensure that it's securely attached to prevent any filament leakage. Now let's talk about the control board. This is the brain of your 3D printer. We're using an Arduino board for this build. Connect your motors and hot end to the Arduino board. Don't forget to connect the power supply as well. Once you've got everything hooked up, it's time for the software. Install the Arduino software on your computer and upload the firmware to your control board. This firmware will control the movements of your printer and regulate the temperature of the hot end. Finally, you'll need to calibrate your printer. Start by leveling the bed. Then, adjust the step per millimeter settings for each axis. This ensures that when you tell the printer to move a certain distance, it moves the correct amount. Run a few test prints to make sure everything is working correctly. Congratulations, you've just built your very own 3D printer. Now you're ready to start creating anything you can imagine. Remember, practice makes perfect, so don't be discouraged if your first few prints aren't perfect. Keep experimenting and optimizing, and you'll be a 3D printing pro in no time. 3D printing is an exciting technology with limitless potential. We've journeyed through its fascinating process, layer by layer, creating objects from digital files. This isn't just a cool tech feature, it's a revolutionary tool that's changing industries, from healthcare to manufacturing and even fashion. We've also explored the importance of 3D printing. It's not just about creating objects on demand, but about reducing waste, saving costs, and even saving lives with custom medical implants. The advantages are clear. It's faster, more efficient, and more sustainable. But perhaps the most empowering part of our journey today has been learning how to build a 3D printer at home. With some basic materials and a little bit of Arduino knowledge, anyone can bring this technology into their living room. It's the ultimate DIY project for our tech-savvy generation. Now the power of 3D printing is in your hands. What will you create?